meeting, and then I'm going to work on this. Hello, Prati. Good morning. How are you?
Hi, good morning. I'm doing good, thank you. How are you?
I'm fine. So before I go ahead, may I know some details from your end, what is your background on the technology? If you are working on what kind of technology and how many years of experience do you have on that?
Yeah, sure. Actually, my educational background is I'm from BBS, commerce background, but I do have completed my SQL Server developer course, and
Great.
I'm working on I have knowledge of SQL Server, file transfer, and little bit basic knowledge of SSIS also. Yeah, that's all pretty much. I'm just entering into the database
Real,
type. Yeah.
right. That's really great, and I would like to inform you that as well that I have around 15 years of experience as a SQL Server DBA as well. So it will be great to have a discussion with you on this. So I think we should go ahead with this demo session today, right? And in this demo session, one more thing, Smriti, I would like to confirm with you. The thing is almost after every slide, I will stop and ask if you have any query or any doubt or any question you have or not. Okay. But it will
Okay.
be great if you can approach by yourself. You can ask your question whenever it comes to your mind. You can just go ahead and ask your question. Okay, don't wait for me like if I complete the entire session, then we'll have a question and answer round. Obviously, we will have something like that. We'll have a kind of
Uh-huh.
question and answer round, obviously, at the end of the session. But it will be great if you can immediately ask your question, immediately ask your doubt on that. So it will be helpful, very much helpful to you, in fact, on that. Okay.
Okay, sure. Sounds good.
Sure. That will be great. Now, if I go ahead about our day-wise activities, day-wise plan, and what is supposed to be covered in our course and all. So, first of all, almost in our first session, we will cover out some details about what is big data, what is what are their various requirements, what are their various use cases, right? We will discuss about various scenarios like how you could identify the big data, like if you get a job or if you get some project on big data in Hadoop, then how will you identify that whether you are going to work on a big data or whether the data you can consider it as a big or not. That is the basic point, I think, right? First of all. Therein you have to define whether you need to implement Hadoop or not. That is also a question, because if you are working for a particular client, your client must be looking for the return of investment, right? He must be looking for the return of investment, and for that return of investment only he has asked you that okay, I think we should implement Hadoop on that and all. But if you fail to identify whether you are supposed to implement Hadoop or not, that is again a point of concern here, right? Because you need to understand first of all whether it is good to implement Hadoop or no. In that case, first of all, you have to identify whether the data is correct or not, right? So first of all, we will give some enough time on this, that okay, whether the data is suitable or not. Once you clearly identify that, once you get a clear-cut concept of that, identifying the data, then we will move ahead like how you can implement the Hadoop. Because there are three basic scenarios, first of all: how, where, and when. Okay, when to implement Hadoop, where to implement Hadoop, and how to implement Hadoop. Right, these are the three scenarios. Then we will have a short discussion about what is Hadoop actually. Hadoop, is it a database? Is it a programming language? Is it a data warehouse? What is that actually? We will have some sort of discussion on that. All right. Let me tell it to you. This is a kind of a framework actually. Okay, it's a kind of framework actually, which consists of all the concerns like programming language. It consists of databases. It consists of data warehouses. Right. It consists of migration tools. Lot of, you can say, it's just a kind of parallel replica, entire replica of what we are having in our current environment. We are having Java as a programming language. we are having SQL Server database as a programming as a database here, right? We are having Oracle data warehouse, right? So the same kind of replica is present in a Hadoop also. That we will discuss. Then we will understand about the programming part of Hadoop. That is a kind of map reduce, right? That is a kind of map reduce. So in that case, in programming part, we will understand like what are the various activities, what are the various scenarios to whom a particular program may pass over there. All right. So we will understand this kind of map reduce in some more details of that. After that, the question here is like if we are having huge amount of data, in that case, how we can process that huge amount of data? This is another question for us. How you can go ahead and process it. If you are simply using basic technologies like DFS or MapReduce and like that, it is simply like you are trying to empty the ocean with just a spoon. Got it? So for this particular purpose, we are having a set of tools that we need to use at the time of analysis of the data. Okay. So we will study all those tools, and before that, I think let's have a shortcut demo of this entire whatever the activities here. So the thing is, first of all, just consider this point that every day, almost like I'm going to say that every section we will have kind of three part and a demo of that particular concerned technology as well. Okay, I will show you a short demo on the server, like how it actually works. After that, you are supposed to complete your small project. At least you will get 4 to 5 different small projects wherein you are supposed to process your data. Okay, I will give you a huge data set, huge set of data you will get. You are supposed to move it, make it in or process that into a meaningful format. Fine. Sorry, 1 second. Let me log out from this because I think I'm getting some calls from here. So, yeah. Now, the thing is, whenever my system fault, yeah. So, during our training program itself, we will be covering some set of interview questions as well. And at the end of this every training, every session, you will get a recording of that entire session along with the study material, and you will get some sort of videos of your concerned technologies. Like let's say I'm going to complete installation part. All right. So installation part, you will get a silent recording as well. That let's say whenever you get placed into some of the company for big data analysis or something like that kind of role, in that case, you can use this video, you can use the manuals directly and openly whenever you can work on accordingly, right? So that you can discuss with Arjuna as well, like how you are going to access all those scenarios. That will be provided to him only, and you can access it from Arjun's portal and all. You can check with him, right? So up to this point, do you have any doubt, any concern so far before we go ahead?
No questions at this moment.
Okay, that's great. And yeah, even do not hesitate, just feel free to let me know if you have any doubt, if you need any specific material, or if you need any more details on a particular topic also. So just let me know, and we will be there to help you out on that. Okay. Now, if I go ahead, sure. Now, if I go ahead and let me give you a brief idea of what kind of different technologies that we are planning to cover over this entire course on this. So as I told you that from the first day of the, I think the first session of the training, we will cover about introduction to big data. First point is keep in mind that we will be having 2 different sets of data. First of all, see, I hope you know very well that what is data. Data is just a raw format. Okay? Data is always in just a raw format, and the collection of this data is called as information. right? Now, let's say if I'm saying just Smriti 24, 36, and something like this. So what does it mean? Like these are just a number here, right? But if I say that 24 is your employee number, right? Smriti is your name, and 36 is just, let's say, the number of set of technology that you know and that you have the code of your application and so on, right? These kind of scenarios, if we discuss over here, then if you combine this data, then it comes to a proper information, right? So data is just a raw format only, and once you combine that data, once you process that data, then only it should come to your particular information. Fine. Now data could be of two types, first of all. First one is your structured data, and the next one is your unstructured data. So the structured data is one which have a definite architecture, which can be stored in different rows and columns, as you might have seen in your SQL Server also, right? In SQL Server, how do you store it? You just create a table like employee table, like employee ID, employee name, and you can say employee age or department or something like that, right? Department ID and something like that. This is what we call as structured data. Another examples, if we discuss, is something like this, like we have payroll data, right? We have student like your attendance sheet, attendance data like this. So these are all your structured set of data, right? Similarly, we have unstructured set of data, that means like that do not have any specific architecture. This in unstructured data include your emails, audio files, photographs, video files, and so on. Now let me give you a very common example in our today's session. I'm sure that you are having your bank account, right? And your bank account statement is the most important document that you will be holding today, right? Now the thing is here, you hardly look at your bank account statement not more than twice a month, right? You do not look more than 2 times a month at your bank account statement, though it is a very important document to you. But if I'm sure that you have your Facebook or you have your WhatsApp or Viber account as well. So the thing is, like on the average, if we discuss here, almost every half an hour, either you are receiving some photographs or video files, or you are sending it to some friend of yours, all right? And let's say you just send one of the video file or one of the photographs to one of your group, group of your friends. Those 10 people send it to another 10 people, like that. So this is just a kind of multiplication of unstructured set of data, right? And due to the development of these kind of mobile devices, social media, right, e-shopping, right, tele-shopping, all these kind of development leads to a huge amount of unstructured set of data. Now the situation is something like that. Out of total data, around 80% of the data is unstructured one. Got it? So that is one of the scenario of our data here. Any doubt on this slide? Any question you want to have?
No, Deep.
Okay. Moving forward, like if we have to define this big data, so this big data in general, I'm talking about in general terms, if we check about, we have 3 different parameters. Though we have more parameters also in some sophisticated environment that we will discuss in detailed session of our training. But here, let me give you some brief idea of this. Briefly, we can identify that there are 3 specific or basic parameters by which you can define your data. You can define it as by the volume of the data, how huge your data is, velocity of the data, how fast you can process that, and variety of data. Like you should have different types of data, like text SMS, like video, like audio, or photographs, and so on, right? Now, if we give some example, if we check out some of the examples over here, like if you go back to around 10 years back, something like that, all of us have Nokia 9910 type of mobiles, right? and we used to send our text SMS to our family members or near Indians and so on. But right now, sending a video, photograph is very, very common today with the help of WhatsApp and all the smartphone technology that we are having right now. Right. This is leading to a collection of huge amount of data. Another thing, let's discuss about some data velocity. Let's take an example of a banking industry. What happens there? It's like if we check about, you can say public hours, start from 10 a.m. to 2 p.m. something like that, right? And after that, bank officers remain inside the bank just to compile up their entire day activities, just to check out like how much fund they have got and how much have been withdrawn from the bank and so on, right? This is a kind of batch processing, right? But now, even today, if I get up at 3 a.m. in the morning and say that, okay, I want to create my fixed deposit, I want to open a fixed deposit, I can directly go ahead on that with the net banking. There is no, nothing to surprise on that, right? So this is what we are discussing about the real-time scenarios. We have a lot of other different scenarios, like we are having some sort of scientific data related to defense services, data related to environment, which leads to the real-time requirement on this, right? These lead to the velocity of data. Instead of using the batch processing, we are going towards the real time. That's the moment you will file your input, the same moment you will get a final output on that. So this is the basic velocity of the data, right? So similarly, if we go ahead and again on the same time around during our school days, if you remember, we used to carry floppy disks, right? Just 12 to 14 KB of floppy disk, if you remember. On that day, like 14 or 12 KB of floppy disks today, even we cannot use them, and not only we can't use that, even our computer systems do not have slots for the floppy, right? But if we talk about today's people who are going to school, carrying terabytes of hard disk is very, very common, right? So here it is. Here it is a scenario that is we have to handle with huge amount of data as well. That is from 14 KB. Now terabytes of data is very, very common. Even a terabyte of data is very common today. These are three parameters that we need to define at the time of identifying the big data. So up to this point, do you have any doubt, any query on this? Any questions?
So it is like basically for the very huge amount of data, like different varieties of data to be in the very like high speed processing. We use big data.
That's a good question. Yeah, that's good. Let me tell you. Let me give you some more explanation on this. See, whether if you identify that big data actually means that huge volume of data, huge amount of data we have, right? That is understandable by the name itself, right? So that means you are getting the amount of data. So let me give you some examples of that. Facebook, they are regularly dumping data of more than 500 plus terabytes on daily basis. Daily basis, they are getting more than 500 terabytes of data. Got it? Similarly, Amazon.com, Google, all of them are getting more than 3 to 500 terabytes of data on daily basis. So if we talk about in general terms, like even if a small industry, a very small company, if it is handling at least 10 terabytes of data on daily basis, 10 terabytes of data is being added to your database. You can understand the point, right? Every day you come to a point that, okay, 10 terabytes of data has been added to your data. Now you can understand that how much disk is required, right? How much disk space is required. And I hope you have heard the word about the performance tuning. Have you studied a chapter of performance tuning in SQL Server?
Yes.
Good. So you can understand that in case of if we are having huge amount of data, how we can perform tune our databases. We can go ahead by making indexes, right? We can go ahead by clearing databases and this. So these are the steps that we need to take handle the huge amount of data. Even then, our process is not at all good in terms of application production, and we can say that. Similarly, if our application or if our database is having multiple set of data, multiple types of data, it is having video recordings as well, it is having photographs. Similarly, like in your Facebook profile, also if you can check, you might find that there are some video recordings, there are a lot of photographs, right? There are a lot of status updates, right? Definitely something on your wall and so on. So what is this? They are having multiple type of data, right? So this is one thing. Another thing is related to working on company. How your company is working actually. Is your company working on real-time analysis or not? Right? See, previously, if we talk about before 10 years back, if we go back to 10 years, in that case, even if you design a Java program that could just calculate a simple interest or compound interest or that, that is enough for
Deep,
us, right? We just execute those programs
excuse
at
me.
night
Hello,
time
Deep.
on business hour. Yes,
Deep,
tell me.
excuse me.
Hmm.
Can you go a bit slow because somehow sometime your voice is breaking. So if you can slow
Oh,
down, would be
okay.
really good.
Then not at all a problem. Not at all a problem.
Yeah,
So,
thanks.
yeah, so Smriti, I think, is there any point have you missed?
No, actually your voice is a little breaking. So that
Oh,
was a hard time for me. That's why I asked question on that one. But now I'm clear. Yeah,
oh,
just
okay.
I think if you go a little slow, then I think it would be okay.
Okay,
Let's
okay, I
try that.
understand.
Yeah. Okay.
No
Thank
issues,
you.
no issues, no issues at all. See, now in terms of velocity, if we are talking about, and velocity, if we are talking about, so see, it depends on your requirement of your client, right? Say, if your client says I need to have a real-time analysis. Real-time analysis is what? Like let's say we can have a kind of environmental data, right? And environmental data, I have to identify huge set of called for events, and I have to process that immediately so that I can predict for the future temperature, tomorrow's temperature as well. It is a kind of capacity planning, something like that. Say we are of the trend of 4, 5, right? And based on that trend, I can predict for the coming 2 to 3 days, right? This is the kind of proactive analysis. So this is just an example of real-time analysis. We will having a lot of different examples we will discuss. So this actually depends on how your company and what is the requirement of your company actually. Based on this, we have identified that whether we have to implement Hadoop or not. Is that clear so far? Swati, is that clear?
Yeah. I'm not sure, like if it is a phone or what. But the Arjun, when he was talking, it was clear.
Yeah, can you tell me once again?
Deep, if you can, bit come
Can you please go
Yeah.
to
ahead once again?
nearby your audio, or you can use microphone. I mean headphone.
Arjun, are you also facing the same issues? I mean, are you also can
Yeah,
feel the voice?
yeah, bit.
No,
I
I
can.
can. Your voice is
The
very clear. Your voice.
hearing is a bit difficult, but overall it's fine. I can see very clear the screen.
Yeah, screen is
That
very
is
clear.
because I can. Yeah, I can hear you very clearly on that. So I think how you have joined? Have you joined to phone or to the audio officer's computer?
No, she has
I
joined
joined to
through
phone.
phone. Yeah.
Maybe I think.
If you can use
Anyway,
headphone, that would be good. Deep. Try using headphone.
yeah, my headphone. Only.
Okay, okay. Then,
Yeah, I'm using.
yeah, now it's fine. Go on, please. You can carry on. All
I
right.
think so see, Smriti, one thing. See, one thing. Even if you got any doubt on a single word, also, even if you miss any single word, don't hesitate to inform me on that. Okay. let me know, or just you can type as well. Screen is open here, and I will definitely help you out to understand on this. Is that fine? Shall we go ahead? Any doubt on this?
Yeah, you can carry on.
Swati is fine. Can we go ahead? I think she is disconnected or something. I don't understand.
No, she's
Anyway,
there. She's there.
okay, fine, fine. That will
Let
be
me
fine.
ask her to join from her desktop. Okay. Baini, are you there?
I think that will be great actually.
Baini, let me call her.
Yeah, that will be fine.
Let's take 5-minute break.
I don't have any concern.
Yeah,
Arjun,
yeah,
please go ahead.
yeah. Let's take 5-minute break. She will download it and she will update it. Okay.
Oh yeah,
Yeah.
right.
Let's take a
Nothing to
break.
worry, nothing to worry.
Yeah. Thanks. Hey, Deep, are you there? Hello, Deep. Hello, Pandey. Deep Pandey. Okay. I think
Yeah, I think
Smriti is
shall we go
there.
ahead now?
Smriti, Baini, are you there? Baini, hello. We can hardly hear you. I don't know. Something is wrong with your audio setting. We can hardly hear you, but I think you can hear us, right? Okay. Then yeah, let's go ahead. And if you have any question, you can just chat on the site. There is a chat option is there, so you can directly have a question to him. All right. All right, Deep. Please go ahead and start up.
Sure,
Thanks.
sure, 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 sure. Right, Smriti. So I think so far we have discussed a couple of examples here, and I have informed you of a couple of scenarios, just basic scenarios here, like where we can go ahead and use Hadoop on that, or we can consider it as a big data. The problem is there are two challenges which are associated with the big data. The first challenge is data storage. Means how you can go ahead and store that huge amount of data. Even let's say a very small company if we talk about, and as I told you that we are having at least 10 terabytes of data on daily basis. Right. Now the question is, every day you come to office and you find out that 10 terabytes of data has been added to your database. Again, it is a problem. Like every day you are going to have, every 2 days or almost every week, you are going to add new hard disk on your system, right? Other new hard disk on your system, or you are sharing some more disk drives, or this kind of scenario, right? So you can understand how costly this effort is right now, right? How costly it is actually. So first challenge is like we should be very cost effective. It should be very cost effective. First solution is that, right? Another challenge is about the data manipulation. Now again, you can understand this. Like if you have read the performance tuning chapter of your SQL server, in that case you can understand very well that if we are having huge amount of data, then what will happen? Even let's say if I have 10 million rows, right? If we have 10 million rows, and now if I have to access only one record, let's say I have a small table like, let me draw that table here. Let me try to make it something like this way. I have a table like employee ID. Okay. I have a column like employee name. Okay. I have a column like designation, right, and so on. Similarly, right, I have this employee table over here with me. Now herein I have around 10 million record. 10 million record. Now I want only one record with employee number 24. How can I do this? I will simply go ahead and fire a command, select a star from table name employee, where employee ID equal to 24. Something like this one, right? The problem is, in order to fetch this single row, this particular query will scan entire 10 million rows of our table, isn't it? It will scan entire 10 million rows of our table. Now you can identify that how much time it will take to perform this action. All right, how much CPU utilization will it take? How much memory it will take on this, right? Now let's say we can go for some another solution of this. That is like, let's say we can create indexes. You might be thinking of that, right? We can create some indexes. But in indexing, if your indexing is enhancing the speed of select query, it will slow down the speed of your insert query, right? It's just a kind of trade-off here. So in order to process this huge amount of data, we should have some dedicated kind of programming methodology. So always remember that these data manipulation is to be done by a specific kind of programming methodology. Okay. In coming slides, we will discuss about what are these, so what are the solutions to address these challenges and all. So any point, any question you have so far? You can just type YURN on the chat window. Okay, I think you can type on chat window because it's very difficult to hear any word from you. I think let us go ahead now. Fine. Now introducing Hadoop. Introducing Hadoop. Good. So you can also type Y or N only. Okay, no need to type no questions and long words over here. Now, as we have already discussed, that the purpose of Hadoop is to store our data economically and process that data in a very speedy manner. Okay. So first of all, the thing is, what we need to do is we have to have Hadoop environment here that will take care of both the challenges. Now what is Hadoop? As I told you very well that Hadoop is basically a software framework that consists of programming language, that consists of databases, that consists of data warehouses, that consists of tools that to migrate data from one location to another location and all. We will discuss a lot of them here. Similarly, this is an open source here. Open source, I hope you know very well. Open source, it is freely available here. Now, this is being utilized over the clusters of self-healing commodity hardware. Now, let me explain each and every word over here. What is commodity hardware? Commodity hardware. Commodity hardware are just a kind of very low-cost computers. Very, very low-cost computers. I hope you remember, like almost 10 years back, 10, 12 years back, especially in India, we have vendors who can design a computer system from the component from different other vendors, like CPU from one vendor, memory from another vendor, disk from another vendor. They just assemble it and sell it at a very low cost. Right. So these kind of computers are actually called as commodity computers. So whenever I'm talking about the commodity hardware or commodity server, I definitely mean it as a server only. Okay, very low cost, very ordinary set of computer. If we talk about kind of comparative analysis, if we see, it will take around $30,000 for a single Oracle server and hardly $4,000 to $5,000 for Hadoop server. Got it? But this is the major difference over there. Now, what is about self-healing here? Self-healing, it means like whenever you add any server on the cluster environment, or if you remove any server from the cluster environment, Hadoop will automatically manage it. Okay, it is not at all going to get down, or it is not going to get unavailable or something like that. No, it will simply manage it accordingly. If one of the server goes down from the cluster list, Hadoop will manage this its own data. It will transfer that data to another server and whatever the activity that we will discuss in some more details later on. Similarly, even if we add any server, it will definitely move it accordingly and move the concerned data to this server, to that newly added server, and make it a part of the application. All right. Similarly, sample we will discuss in our detailed session as well. Okay. Once we go ahead to the detailed session, this is just a kind of demo what we are going to have in our actual classes. Fine. So sample, and not only the sample, we will discuss about like how we are going to use this and what is the basic process behind this, how it detects actually, and how it is going to identify that the new server has been added and all. And not only the new server added, then theoretically we will have a kind of practical session also on this. Okay, I will show you that if you have to add any new server on the cluster environment, how you could do that. Fine, but this is just a demo session, so that it's just a point of, we are discussing like what are the various technologies that we are supposed to study in coming 24 hours of training. Fine. Now, simply go ahead. Now, the primary components, basic components. We have just seen two different challenges of Hadoop. First challenge is storage of data. Yeah. Don't worry. Even I will not show you. You will get it yourself itself, right? You will be supposed to install Hadoop in front of me. You have to follow my steps. You will see that by yourself that how it actually looks like. What are the various precautions that you need to take, right? You will get at least 2 to 3 chances to install Hadoop on a server, on a remote server, and how you can access that and how you can work on that accordingly. Fine. Yeah, it's not only me. I am here to help show you that, but you will get it yourself also. Fine. And ultimately, if I'm talking about the project, that's what I told you at the beginning. The project is something like I will just give you a set of data, right? And I will give you some set of tasks that you are supposed to perform on that data. Then I will give you access on the server. Then what you need to do is simply go ahead, log into that server, install Hadoop on that, complete your project, and send a report back to me. Fine. So you have to do this at least. Yeah. So at least I'm not going to the maximum number. I'm not going to the maximum number. I'm just going to at least you have to complete 4 different projects. It consists of programming one project for programming language, for databases, then programming and database connectivity, and then how you can speed up your processing and all. So we will discuss that later in coming slides as well. No worries. Now about the primary components over here. Like as I told you that there are 2 challenges that are posed by big data. First challenge is associated with obviously your data storage, and another process is like your data processing. So for the data storage part, we have environment called a Hadoop distributed file system. Just like we have Unix file system, we have Windows file system, right? Similarly, we have Hadoop distributed file system, which actually stores your data. Okay, that you can store that data in terms of your file, in terms of your log file, in terms of your CSV file. That you will do this by yourself only once we go ahead in the more details of that. Okay. Another challenge is about the processing of the data. So this processing, you can do this with the help of MapReduce. Okay, MapReduce is basically a kind of programming methodology which helps in a kind of parallel or distributed data processing. Now, one thing just keep in mind that MapReduce is not at all a programming language. This is your programming methodology. Okay, you can write your MapReduce program in Java, in C++, Delphi, Python, any of the programming language. That's it. But this is just a way of writing a program on that. So we will discuss that in coming sessions also, once we go ahead to the details of this MapReduce. Fine. Now, as I have told you that we will be having some discussions on Hadoop ecosystems, various ecosystems which are associated to Hadoop environment. The thing is, like if you are writing a program or Java program on MapReduce, what is called, one second, let me answer your question first. What is called for programming language which we write in Hadoop? See, first of all, if you are writing a program in Hadoop, there are a few, wait, I got it, I got your point. See, first of all, one second, see, first of all, Hadoop is actually written in Java, okay? Hadoop is just written in Java. And if you are going to write a program in Hadoop, you have to follow the structure for MapReduce. Okay, MapReduce, you can write your MapReduce program in Java, C++, Delphi, Python, any of the programming language. Okay, you can use any programming language to write a MapReduce code. The way is just the scenario here is just a different way of writing a program. So I will let you know like how you can write a program as well. But another point here, that's the most exciting point to be come out on this ecosystem part. So your question is like what is called programming language. Programming language, you can use any of the existing programming language. But how you have to write it, you have to write a program in a way that you can use a MapReduce part. That's it. The way MapReduce is just a style of writing a program. That's it. Okay? Is that fine? Smriti, is that okay? Can we go ahead? Okay, fine. No, and don't worry. You don't have to write a lot of these big programs also. Okay, we have a very good or very exciting ecosystems that are coming in next slide. All that. Okay. The question is like if we are having a storage part, if we have like we have provided a challenge for the storage part, and we have covered up the challenge for the programming language also. Then why do we need this ecosystem? This ecosystem is like, I hope you have worked on SQL Server Management Studio, right? I hope you know very well that you can work on, I hope you know very well that you can work on SQL Server with command line prompt also. Are you sure? Have you done it? Command line prompt? Have you accessed? Right. So you can work on, no. Yes, you can work on command line prompt also. Okay. With the help of just you can go ahead with the command line prompt and you can fire your command on command line itself. But why we are using SQL Server Management Studio? The reason is because it is first of all making our lives little bit easier as compared to handle the command line prompt. Another example, if you can say that, you can access your Windows disk drive through command line prompt, right? You know very well. But we prefer the GUI console. Why? Obviously, this is easy to handle, and it will be great. Like if we can save our lot of time also by handling our system through the GUI console as well, right? So that's the main reason why we have a lot of ecosystems which are being designed to access and process the data which is present in our Hadoop environment. Yeah, absolutely right. It is easy as well as it is very, very effective. So now I think let us go ahead with the ecosystems over here. And these ecosystems, yes, these are not only just a part of Hadoop environment, they have their own definite specific entity as well, and these can be used whenever we are having huge amount of data, and we can use it effectively so that we can process it in a desired manner. So our first ecosystem is yarn, yet another resource negotiator. Okay. So I'm not going to all the details of each and every ecosystem because we will be studying all of them one by one in our detailed session. But let me give you a basic introduction part of the job. First of all, I hope you have done some online shopping, right? You have already done. I hope you have visited the Amazon.com or Flipkart or eBay or something like that. So what are various scenarios on this? On one hand, you can do some shopping on that, right? Another hand, you can chat with the customer representative, right? Next, you can write reviews on different products, right? You can you can pay your bills as well, right? Through credit card or debit card on these e-commerce website. At least 4 to 5 different functionalities are there on the same site. So yarn is actually used when we are supposed to implement different number of different types of applications on a same cluster of the server. Okay. I hope this basic definition is clear to you. For details, don't worry, because we will be going on very much detailed analysis of these ecosystems. Okay. Another thing is HBase. HBase. So I hope so far you know very well that we are using SQL Server or Oracle database, right? In SQL Server, how do you store your data? How do you store your data? Let me show that to you. Let's say, yeah, let me take this table only. Okay. Designation, and one column is, let's say, department, right? Let's say your 001, this is Amit. Okay, designation is, let's say, manager. Department is, let's say, IT. Okay. Similarly, 002, name is say Rajiv. Okay. His designation is not known to me. What can I do? I can simply store null over here. Right? Department not known to me. I can store null over here. 003. Right? We can have one more person as Sudhir. Designation is, let's say, IT analyst. Department not known to me. I can type null here. Right? And I hope you know very well that null also occupies a couple of space in your database. Right? Now, the thing is, you can observe in this particular table, we have only 3 records. We have only 3 records, but we have 3 nulls over here. Now, can you imagine if we have 5 million or 10 million records? We will be having 10 million nulls. So you can understand like how much huge amount of space we are simply wasting here. This is good for nothing, in fact, right? But in case of HBase, this is your SQL. Let's say this is your SQL table. Okay, this is your row format. You are storing your data into row format. Okay, it is called as row-oriented database. But in case of HBase, you need not to store null value. You can simply store for employee ID, let's say employee ID, let's say it is 002, right? Employee name is Rajiv. You don't have information about designation and department, you need not to store that. Similarly, for employee ID 003, right? We have information about employee name, so we will store it as Sudhir. Fine. We have information about the designation, so we will store it over here. We do not have information about the department, so it is not at all required to store here. This way, not only you can save your space for the data, but it is also helping you to increase the processing speed as well. But how it is being done, we will see that. And again, let me tell you, you will get one more project on that you need to store this kind of data and you have to process that as well. Fine. Feeling exciting? Is it fine? Shall we go ahead? Great. Now, Hive. Hive. What is this? This Hive is basically your data warehouse kind of environment. This is basically kind of a data warehouse. In this kind of data warehouse, you can use a SQL-like language called as HiveQL. You have studied SQL very well, right? And you know very well that writing a SQL command is very, very much easy as compared to writing a Java code. Am I right? So here in case of Hive, you can use a SQL-like language that is called as HiveQL. This is acting as a data warehouse. You will again get one project on this that you need to process your data over the Hive. Fine. Similarly, we have a programming language that is called as Pig. Okay, this Pig. Why it has a name like Pig, we will discuss that later. But let me give you a very, very exciting functionality or feature of this Pig programming language as compared to our Java or MapReduce programming languages here. See, instead of saying a lot of words, just a one-word answer over here. If you are realizing a functionality with 700 to 800 lines of code of Java, you can realize the same functionality with the help of just 5 to 8 lines of code of Pig. Got it? You need not to write 700 to 800 lines of code of Java like that. You can simply write just 5 to 8 lines of code of Pig and you will realize the same functionality over there. You will get one more project on that Pig as well. For each and almost for every technology, I will try my best to provide you the project and you are supposed to complete that as well. Fine. So we will have a detailed analysis of that later on. Similarly, we have Scoop. Now you know very well that you are having a huge amount of data in SQL Server. Okay, daily you are getting your data. Now the question is, let's say some fine day your client comes to you and says that I want to transfer the data which is present in your SQL Server to the Hadoop environment. How you could do that? Right. So in that case, you can use this Scoop functionality. This is the kind of tool actually that you might use it for importing or exporting the data in both ways. That means you can move your data from SQL Server to Hadoop and vice versa with the help of this Scoop tool. Fine. Similarly, we have, is it a separate tool? Yeah, this is built in within Hadoop only. This is built in within Hadoop only, but this is just a tool. Fine. Similarly, a Zookeeper. Now, so far you have seen a lot of tools, you have seen databases, programming language, data warehouses, and you know very well that we are having a lot of different servers, hundreds of different servers of Hadoop. How they are managed actually? they are being managed with the help of Zookeeper, which is a very, very important functionality in terms of Hadoop. Got it? So we will have some discussion on Zookeeper also once we go ahead. Similarly, okay. Similarly, we have Chukwa and Flume. We will study about Chukwa and Flume as well. In Chukwa and Flume, what are these actually? I just told you about Scoop. That means you are moving your data from SQL Server to Hadoop. That means, yeah, these are a little bit weird and very much interesting as well, and the functionality is also very interesting. So as we have just seen about Scoop, the Scoop is moving data from SQL Server or Oracle or MySQL, any kind of external database, to Hadoop environment, right? And vice versa, obviously. Now, Flume and Chukwa are actually being used to transfer the data within the servers itself. Okay, like you are having hundreds of different servers and you need to move, let's say, 100 terabytes of data. If you directly go ahead and copy and paste that data, you can understand like how much time it will take, how much network it will utilize, and so on, right? It will hang our entire network over there if you move this huge amount of data. So we are using these two functionalities, two tools are there, which will help us to migrate data within our cluster environment. Fine. So we will have some short discussion on that as well. Similarly, we have something called as Oozie. Now let us say your client comes to you and your boss comes to you, says that just design a job which will process the data with the help of Pig, okay, and the output will be stored in Hive. Okay, getting my point? You are having some data. You want to process that data with the help of Pig, and then you want to store that data in a data warehouse. Okay. Now, this, and again, your boss says that every day morning 4 a.m. you are supposed to execute this task. Now again, it's a kind of difficulty. So what you can do is, I hope you have heard about the SQL Server jobs, right? SQL jobs you have heard of. Yeah. Just like SQL jobs, as you can schedule those jobs. I hope you have worked on, I think, SSAS. Have you worked on SSAS? SSAS. Okay, okay. Then not at all a problem. So, yeah. In case of Oozie, you can design your job this way, and you can schedule it accordingly. Okay. This is a kind of job creator actually, Oozie. Fine. So we will have a kind of demonstration of that, and we will study that as well in some details. Similarly, we have Mahout. Mahout is basically a kind of machine learning algorithm. Fine. So this is just a machine learning or intelligent processing as well. We will have some session on that as well. Moving ahead, we have a database called as Cassandra. Okay, this is again a kind of NoSQL database. This is just like your HBase only, just like your HBase. Data store is in the form of HBase only, but this also provides you a query language which is very, very similar to your SQL language, and this is called as Cassandra query language. Okay, so we will not only discuss these technologies, we will also let you know that which company is responsible for the innovation of which specific technology. Like, let's say Hive was actually developed by Facebook, right? Pig was actually developed by Yahoo. Cassandra was actually developed by Amazon, right? So we will go ahead and study their case studies as also, that why they what are the circumstances that lead to the development of these kind of technologies as well in our detailed session. So at least these are the points that we will be covering. Apart from that, I hope up to this point, is that fine with you, Smriti? Any question you have, any doubt so far? No, Smriti, there is a lot of background noise as well from your side. If you can just write your query, I think that will be much more helpful. Well, I understand that you might have a lot of doubts, obviously, because you have heard of all these terms for the first time, and a little bit, different kind of technologies are there. So obviously, we will be going to treat all of them in our detailed session. But apart from that, if you have any question, actually, I think this is more useful and useful. Not only financial sector, Smriti, not only the financial sector. These are, yes, you are absolutely right. Yeah, absolutely right. Absolutely right. See, financial sector, if we are talking about, yes, obviously they are being used in the financial sector. In medical sector, if you are talking about, I have just gone to one of medical giant here, that is United Health Group. Okay, they are also using, and I was the chief instructor on that as well. Right. So don't worry, I have a lot of different use cases wherein you can use it in the medical domain, you can use it in a kind of banking, obviously, retails, your financial environment, your defense, your environmental, and moreover, I hope you have heard about the Large Hadron Collider as well. Right, it's a machine which is running to identify the occurrence or sustaining of the universe. Right, scientific data analysis. So we will discuss all these details once we go ahead in our detailed analysis session also. Of course, yeah, definitely. We will be having a domain specific area as well. Any more doubt? Shall we go ahead now? Okay, great. Then we will cover up some part of Hadoop administration also. It is not at all limited to this part only. We will cover this just a kind of, as you know very well, this is just a demo session, and we are just taking part of go through of all the technologies here. So we will discuss about like single node Hadoop installation, cluster installation, how you can add or remove clusters, how you can add or remove nodes, how you can add or remove services, start services, stop services, how we can avail TFS high availability backup, as well as we will discuss about the security part also. And also I will let you know what are the various improvements we are going to achieve in our coming time. Right, because you know very well that this Hadoop is, as I told you, this is an open source technology, and lot of people are working on this from dusk to dawn on this to understand and to develop a new kind of ecosystems on daily basis. Right. So I will also let you know like from where you will get this kind of information. Right. From where you will get updated patches of that Hadoop itself, and from where you will get some idea like what kind of ecosystems you can develop and all. So yes, that we will also discuss here. So I think to this point, this is the last slide here. If you have any query, any doubt, you can write it over there. Okay, I think so. We can log off for today, and that is just a last slide on this. And thank you from my end as well. So
Right.
I think you can check with Arjun. Arjun, can you please help Smriti to decide the timing and all, and let
Yeah,
me know
sure.
accordingly.
We will continue from next week, 29, 30. Yeah, the first class will be on 29.
Okay,
I think
29.
yeah. Tomorrow is
Okay.
having they are having kind of like a rush time or something.
No,
So
no, no, no. That's not at all an issue.
hmm, hmm.
That's not at all an
All
issue.
right. In the
So
meanwhile,
just
I will
check with
communicate you,
time.
Deep.
Yeah, I think that will be good. Just let me know, and I will be there to help you out.
Sure, sounds good. Thank you very much. All right. Thank you for
Yeah, most
joining.
welcome.
Mhm.
One second. From next weekend, I will. Yeah, yeah. Okay, Smriti, that's all right. You can just check with Arjun, and he will let.